Decrease and conquer design technique. First, let us see general plan for decrease and conquer. Reduce problem instance to smaller instance of the same problem. Then solve smaller instance. Then extend the solution of smaller instance to obtain solution to original instance. So these three steps you are required to perform in order to find solution for a given problem using decrease and conquer design technique. This can be implemented using top-down or bottom-up approach also. This way of finding the solution is called inductive or incremental approach. So as the name itself suggests, that is decrease and conquer. The first stage is decrease stage and the second stage is conquering stage. In the decrease stage, the problem size is to be decreased. Second stage is conquering stage, that is finding the solution. Conquer means find the solution to the original problem. This can be achieved by finding the solution to the smaller instance, then extend the solution of smaller instance to get the solution for original problem. Now we'll see how you can decrease the problem. Problem can be decreased by three ways. The first one is decrease by constant and the second one is decrease by constant factor. The next one is variable size decrease. So let me explain what is decrease by constant here. You have given a problem of size n. Then reduce the problem to the smaller instance of size n minus 1. Find the solution to the sub-problem. Then extend this solution to get the solution for the original problem. For example, let fn equal to a power n. So then how do you find a power n minus 1? So assume that already you know the solution for a power n minus 1. If you already know the solution for a power n minus 1, then you can find a power n is equal to a power n minus 1 into a. That's it. So if n is greater than 0. If n equal to 1, then a power 0 is equal to 1. So here the problem is decreased by 1. The problem size is decreased by 1. So if you know the solution, here already you know the solution for a power n minus 1, then with that you can find the solution for the problem of size a power n. Next, we'll see decrease by constant factor. Given a problem of size n, reduce the problem of size n by 2. Find the solution to the small subproblem. Then extend the solution of this subproblem to get the solution to the original problem. So assume that already you know the solution for a power n by 2. Then you can easily find a power n. How? By squaring this. When n is even and positive. When n is odd, so you need to find, if you know already a power n minus 1 divided by 2, just square this into a will give you a power n, and as usual the base condition is when n equal to 0, a power 0 is 1. So now we'll see exponentiation by squaring here. You are required to find out a power n by decrease by constant factor method. So here the problem size is decreased by constant factor 2. Now this can be written as a power n is equal to a power n by 2 whole square, that already I explained in the previous slide. So when n is even. And the base condition here is a power 0 equal to 1. When n is odd number, then this is how you are going to write it. So basically what you are doing here is you are multiplying, that is, if you already know a power n by 2, then you are finding the square of this. That means multiply a power n by 2 into a power n by 2. So you need to count how many multiplications you are required to do in order to find a power n, right? So the basic operation performed here is multiplication. So the time complexity of this finding the solution for a power n is dependent on number of multiplications performed in order to find a power n. So if you want to count how many multiplications is being performed to find a power n, then you need to know how many multiplications is being done when the problem is reduced to half plus fn. That is, if you want to find out solution for a power n, you need to know a power n by 2. So here, when n is even, you are doing one multiplication. Look at here, 3 power 4. Then if you already know 3 square, then how do you find 3 power 4? Just square it. That is 9 square, 9 into 9, only one multiplication. If you want to find out 3 power 5, already you have found what is 3 square. So 3 square into 3 square, that is 9 into 9 into 3. So 2 multiplications you are doing. So Fn can take the value 1 or 0. 1 or 2. And when n is equal to 0, a power 0 equal to 0. So this is how you can write the recurrence relation to compute a power n by decrease by constant factor method. Look at here, we'll analyze this algorithm for 3 power 4. So in order to find out 3 power 4, so you need to know what is 3 square. That means this problem will call again 3 square. So in order to find out 3 square, it will multiply 3 into 3, that is 9. That is equal to 9. So already we know what is 3 square. It's 9. So 9 into 9 is 3 power 4. So here one multiplication and here another multiplication. In order to find out 3 power 4, only 2 multiplications is being performed. In case if you want to find the solution by using brute force, so what brute force is? A power n is nothing but multiply a n times. So how many multiplications you are required to do? Here 3 multiplications you are required to do. That is a, that is 3 into 3, then into 3 into 3. So 3 multiplications you are required to do in brute force, but in decrease by constant factor you can able to find the solution for 3 power 4 by multiplying this 9 into 9, that is 1 multiplication. In order to find out 9, that is 3 square, 1 multiplication. Totally only 2 multiplications you are doing in order to find out 3 power 4, but in brute force it is 3 multiplication. Here also in order to find out 3 power 5, 1, 2, then for this to find 3 square you are doing one more multiplication, only 3 multiplications you are doing, but in brute force you need to perform 4 multiplications. So in general you are required to find out the number of multiplications in order to find out a power n. So if you want to know what is a power n, okay, so you need to know mn multiplication. So in order to find a power n, you need to know what is a power n by 2. In order to find a power n by 2, so you need to know how many multiplications is being done when the problem size is n by 2 plus Fn. So that is when n is odd, 1 multiplication, and when n is when n is even, 1 multiplication, and when n is odd, 2 multiplications are performed. So m0 equal to 0. So when you apply the master theorem, this is a solution what you are going to get. Now we'll see what is decrease by constant factor. So decrease by constant factor, the name itself will suggest you that in every iteration, problem size is reduced by in earlier case problem size is reduced by constant factor, but here the problem size reduction is not constant, it's variable. So here it varies from one iteration to another iteration. So example here is Euclid's algorithm for finding greatest common divisor, partition based algorithm for selection problem, then interpolation search, then some algorithms are binary search algorithms, NIM and NIM-like games. So now in decrease by constant factor algorithm, so binary search and the method of bisection, then exponentiation by squaring, Russian peasant method, then fake coin puzzle, Josephus problem. These are the example for decrease by constant factor. So I was discussing this variable size decrease here. So in variable size decrease, as I told you that the problem size reduction varies from iteration to iteration. For example, to find the GCD of these two numbers 80 and 44, so first look at here, the problem size is reduced like this, and next iteration like this, and here like this. So the problem reduction is obviously dependent on the second number. So let me summarize what we have discussed in decrease and conquer. As I told you that in decrease and conquer, there are two stages. The first stage is decrease the problem size, and then conquer stage, that is find the solution for the original problem. So this problem reduction can be done in three ways. The first way is decrease by a constant, decrease by a constant factor, and the third method is variable size decrease. Decrease by a constant examples are insertion sort, graph traversal algorithm, DFS and BFS, topological sorting, then algorithms for generating combinatorial objects like permutations, subsets, etc. So in this chapter, we are going to study these algorithms, that is insertion sort, graph traversal algorithms, topological sorting, and algorithms for generating combinatorial objects. So now, so already you have learned what brute force is, divide and conquer technique, and here I have just given you introduction what is decrease and conquer, that is decrease by 1, especially when I say decrease by constant, it is the problem size is decreased by 1, and decrease by constant factor, here we are decreasing by factor 2. So when you apply these techniques to find a power n, okay, I wanted you to find the difference, like what will happen to complexity of the algorithm. Thank you.